Okay, so we're going to do a continuation of 2.6, and this is going to be combining vertical and horizontal shifts. But before we do that, let's just take a look at the last exercise, which was doing the following graphs: x minus 1 cubed and x plus 1 cubed. And hopefully you could see that the base graph is just x cubed. So let's graph x cubed, something like this. And let's label one point here, 0, 0. Now this is of the form x minus 1 cubed. So this is f of x minus 1. And that is a shift to the right by 1 unit. So for f1, the graph is going to be as follows. We take one point, say that point, and move it to the right by 1. So we have 1, 0 here. Notice that point is correct. If you plug in 1, you'll get 0. And then you just draw a similar graph. So this is the graph of f1 right here. And a similar story is there for f2. So f2 of x is x plus 1 cubed, which is f of x plus 1, and that's a shift to the left by 1 unit. So what we do is we say, okay, let's take that point 0, 0 in the original graph, move it over by 1 unit to the left, meaning to negative 1, 0, and then draw the same graph. So this is negative 1, 0. Okay, so that's the exercise from last time. What I wanted to do is do a couple of examples where we combine horizontal and vertical shifts. And we'll do this using the absolute value function. So let's take, say, the absolute value of x plus 1 minus 2. Or let's call this f tilde. Notice here our base function f of x is just the absolute value of x. Now how do we get to f tilde, where we start with the absolute value of x, then we do one transformation, which is shifting. This transformation is a shift to the left by 1 unit. And the next transformation is that we subtract 2. So this is a vertical shift down by 2. So what we can do this stage by stage if you'd like. The original graph of absolute value of x is this V shape. And so this is this guy. Then we shift by 1 to the left. So negative 1. And the final graph then is shifted down. So here's the point 0, 0. Here's the point negative 1, 0. And then the last graph, which is our final function, is going to be shifting down by 2. So negative 1 and then down by 2. This is point negative 1, negative 2. So this is the procedure for combining multiple shifts. You first I mean, this is, you can, once you get used to it, you can go directly to the final product. But for now, maybe it's a good idea to do one shift at a time. Let's do one more example. And this is with the base function is going to be 1 over x. What we want to graph is, say, 1 over x minus 1, and then plus 2 overall. So let's first recall how to graph the original graph f, and then we'll do the shifting process to get to f tilde. So this is 1 over x. Recall that this is the graph with those asymptotes. So this gets closer and closer to infinity here. There's an asymptote, a vertical and a horizontal one. And so probably, you know, to be kosher, this whole thing should be asymptotes. And similarly, this horizontal piece should also be as well. So how do we get to the f tilde function is the question. And let's maybe label a point here. Let's label one point, which is 1, 1, just to have a reference. Well, to get to f tilde, what do? We do two shifts. First shift is to do 1 over x minus 1. All right, so we're replacing x with x minus 1. So this, let me keep this aside. This is a horizontal shift to the right by 1 unit, because you've replaced x with x minus 1. Then I have added 2 to that entire function. So this is a vertical shift up by 2 units. So what do our graphs look like? Let's take a look. So let's first graph 1 over x minus 1. What does that look like? Well, I take the original graph and I shift it to the right by 1, which means my vertical asymptote now looks something like this. My horizontal asymptote, let me put that in blue here. Oops. So in blue, let me just, the vertical asymptote here. I'm doing asymptotes in blue, so let me continue that. Since it's a horizontal shift, the horizontal asymptote continues to stay where it is. And now you draw the graphs like so. And let's label at least one point here. This point will shift to the right, which means this becomes 2, 1. Okay, that original point 1, 1 became 2, 1. And now let's graph the final graph, which is, let's put it over here. Well, we need to go up by 2. So what's going to happen is this horizontal asymptote, which was originally this horizontal asymptote right here, that's going to go up by 2. So 1 and 2. So we draw a horizontal asymptote here. The vertical asymptote, well, we're shifting upward. A vertical asymptote is infinite. So our vertical asymptote stays at x equals 1. Okay, so those are our asymptotes, and now we draw our graph. And now we label, well, this point 2, 1, it went up by 2, so let's draw the same point. This is the point now, 2, 3. Okay. So this is our final graph of f tilde of x, which was 1 over x minus 1 plus 2. Okay, let me leave you here with an exercise. So go ahead and graph f tilde of x being, let's use the absolute value again, x minus 4 minus 6. And let's have you guys do one more here. Call it g tilde of x being 1 over x plus 1 plus 2. Okay, so we will start the next video with these exercises, and we'll stop here for now.